Well, hey there, it's that coding guy here, breaking it down and making it accessible. Let's talk about for loops. If you have a block of code that you would like to run more than one time, hopefully a few times maybe, then a for loop may be the solution for you. So I would recommend that if you haven't yet tackled conditionals or if statements, to go check out my video on those guys, because we're going to use the same sort of concept. And that is that the code inside a for loop is going to execute as long as a condition evaluates to true. And as soon as that evaluates to false, we're going to break the loop. So the basic construct here, you could do worse than going to check out the Java tutorials for the for statement or the for loop. And they've got this handy dandy little blueprint that we can make use of here to try to understand how to build a for loop. So I've got that kind of hanging out up here. And so the for loop starts off with the keyword for, and then we open some parens. So the initialization section of this will be us initializing a loop counter, and that's going to keep track of how many times the loop is going to execute. So it's very typical to start at 0 or 1 for lots of applications, but you can start from anywhere, and you could also use another variable that's already declared elsewhere. But for our purposes here today, I'd like to think about printing out the numbers between 1 and 10. So for our purposes, we want to start at 1. So I'm going to say int I is equal to 1. Now, if you've heard me talk in my other videos, I talk about variable naming practices and best practices. And variable naming means using contextual names and good names that tell us what's going on. This is going to be one of the exceptions to that rule. It's very common to see loop counters as either I, J, or K. And it's part of the reason for that is because this variable in particular is only going to be useful during this loop. It's not going to be used elsewhere outside of that loop. It lives within this loop context, and that's it. And because we're not passing it around and referring to it in other places, it's okay to use I. The thing that will get you in your career probably at least once, maybe more, is the fact that these different sections here are separated by semicolons, not commas. So if I had started this off right here with a comma and we went all the way through here, it would be yelling at me. It wouldn't be sure what's going on. So look out for that. Make sure you use a semicolon there. All right. The next part is the termination or the condition. And this is where your knowledge of if statements is going to come in handy. Because in essence, the body of our loop is going to execute as long as this condition is true. As soon as this condition evaluates to false, we're going to break out of the loop. So if we wanted to print the numbers between 1 and 10, and we're starting at 1 and going to 10, we probably want to break the loop once the counter gets to 10. So I'm going to use I is less than 11. So as long as that's true, we're going to loop again. And finally, we've got the increment. So if you're not familiar with this I++, or I minus minus, let's talk about that real quick because you're going to see this a lot with loops. I++ is basically shorthand for I is equal to I plus 1. And likewise, I minus minus is equivalent to I is equal to I minus 1. So it's really just adding one or taking one away whenever you see this. And actually, we can talk about this real quick and just show this. If we said I is equal to 1, and then we do I plus plus, and then we check out the value of I, we're going to get 2, right? Well, if I comment out my bad syntax, we would. So there we go. We get 2 because we just incremented it by 1. And likewise, if we had done minus minus, what do you think we're going to get? I think we're going to get 0. So that's a little primer on those guys there. So back to the loop that we were building. We want this, whoops, that was space. We want this to increase our counter every single time that we go through the loop. So we're going to do I plus plus. And this is saying, hey, that for statement has an empty body. That's right, we haven't put any code in here yet. So it's this block of code that's going to execute every time through the loop. And we can have as many lines in here as we want. We could have other loops in here. We could call other functions. You can do whatever you want in here. So what do I want to do? I want to print out some numbers, man. So we'll use our little sout here and get us that system print line. And what we can do is print out the value of I every time we go through the loop. So once again, just a recap here, we're starting with I equal to 1. We're initializing this new variable here that's used in the loop. And the first time that we run this, it's going to say, hey, is I less than 11? 1 is less than 11. So this evaluates to true. That means we will execute the code inside the loop body. And as the very last thing that happens, that counter will be updated with this incrementer. So we print out 1, we come in, we increment I to 2, and then we check it again. Is 2 less than 11? Yes, it is. And okay, then we're going to execute the body of the loop again. And the last thing it does is increment 2 to 3. We check it again, and so on. Until the last time when we have printed out 10, we increment I to 11, and we check it. Is 11 less than 11? No, it's not. 11 is equal to 11. So that evaluates to false, and we break out of the loop and then continue execution on down through the rest of the file. So things to look out for, once again, making sure that you're separating these by semicolons. And you also want to be careful not to get yourself into an infinite loop. Now, if you had another variable out here like int j, and you accidentally base your loop break criteria off some other variable, and we ran this guy, you can see that I is getting printed out here, and it's incrementing pretty quick. And this isn't going to stop. So this is an infinite loop. And I'll just stop the program here. But what we did is we based the loop criteria off of j, And because j is not the one getting changed, j is always zero, and therefore j is always less than 11. And so this would just continue on. So you definitely need to be careful about those, and you can see how fast these ran, because already we were up to like 15 million just by having run this for several seconds. So pretty cool stuff there. So watch out for your, and it is, IntelliJ here is trying to warn us, because if I hover over this, it says, hey, j less than 11 is always true, and this doesn't seem like what you want. So take a look at the things that your IDE is trying to point out. It's usually trying to help you, even if it seems like a pain sometimes. So cool. That is mostly for loops there. And if we wanted to do this the other way around, we could definitely start at 10. We could definitely start or end as long as I is greater than 1. And if we decrement, we could run this guy backwards. So that, oops, as long as it's greater than equal to 1. Rookie mistake. We're going to get 10 through 1. So you also want to be careful with your termination, right? Do we want greater than this or greater than equal to what? Can make or break your loops. And there are other types of loops out there as well. There is the while loop, there's the do while loop, and there's an enhanced for loop that has a bit of a different syntax. And I'll cover those in additional videos. But for the most part, things that you can do in one loop, you could do in the other type of loop just by rearranging a couple of things. So hope this helps. And if you like this content, please give me a thumbs up on the video, throw in a comment. Helps the channel. And we'll catch you on the next one.